Good evening, class 11. Let's continue with the topic. Metallic character. So what is metallic character? It is the tendency of an atom to lose electrons and form cations. It depends on two factors, that is atomic size and nuclear charge. Atomic size, nuclear charge. Now, what happens when the atomic size increases? As the atomic size increases, the distance between the nucleus and the outermost shell increases. So the nuclear attraction on the outermost shell is lesser. So it is easier for the atom to lose electron. Okay, so metallic character increases with increase in atomic size. When the nuclear charge increases, the nuclear attraction on the outermost shell increases. So it becomes difficult for the atom to lose electrons. So with increase in nuclear charge, the metallic character decreases. Downward arrow. So it is directly proportional to atomic size and inversely proportional to the nuclear charge. Now when we talk about the periodic trend, on moving down a group, atomic size increases, nuclear charge also increases, but the increase in the atomic size dominates, right? So due to increase in atomic size, the distance between the nucleus and the outermost shell increases. So the nuclear pull on the outermost shell is lesser. So easily that atom can lose electron. So down a group, the metallic character increases. Okay. On moving across a period, the atomic size decreases. Effective nuclear charge increases. As a result, the nuclear attraction is more. So it becomes difficult for the atom to lose electrons. So metallic character decreases on moving across a period. Now we come to non-metallic character. Non-metallic character, it is a tendency of an atom to gain electrons and form anions. Right? It also depends on atomic size and nuclear charge. So what happens when the atomic size increases? When atomic size increases, distance between the nucleus and the outermost shell increases. As a result, the nuclear attraction is lesser. So tendency of the atom to gain electron will be lesser. So non-metallic character with increase in atomic size will decrease. With increase in nuclear charge, the nuclear attraction is more, so it becomes easier for the atom to gain electrons. So non-metallic character will increase with increase in the nuclear charge. Right? So it is directly proportional to the nuclear charge and inversely proportional to the atomic size. When we talk about the periodic trend, on moving down a group, the non-metallic character decreases, and on moving across a period, the non-metallic character increases. Okay, next we come to the reactivity of the elements. Reactivity. Now reactivity basically depends on the tendency of an atom to either lose or gain electron. That means it will involve both metallic and non-metallic character. Now usually what do we see? On moving down a group, the reactivity increases, and on moving across a period, the reactivity first decreases, then the reactivity increases. Now we need to know that in the periodic table, the left hand side, that is the extreme left of the periodic table, is occupied by the metals, and the extreme right of the periodic table are occupied by the non-metals. It is fluorine, chlorine, sulfur, oxygen, right? So the left hand side of the table contains metals and right hand side contains non-metals. As a result, the left hand side, my elements will be more and more metallic, my metallic character will be more, and right hand side, my non-metallic character will be more. So if I consider group 1, if I consider, I have what? Lithium, then sodium, potassium. So these three elements we have. We also have rubidium. So on moving down a group, we get to see the reactivity increases on moving down a group. That means what? This increase in the reactivity is due to the increase in the metallic character. Okay, so reactivity down a group increases because of the increase in the metallic character. When we talk about across a period, if I consider period number 3, I have elements sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So If I consider this period, what do we observe? That the reactivity first decreases and then increases. if I compare their reactivity, my sodium, magnesium, aluminium, they are metals. Now obviously the metallic character will be decreasing as I move from sodium to aluminium, right? So silicon is a metalloid. Then we have all the non-metals. So as I move from sodium to magnesium and aluminium further to silicon, what do we see? The metallic character decreases, due to which the reactivity will be decreasing. Then from phosphorus, my reactivity again starts increasing. Why? Because the non-metallic character increases, right? So in a period we have both metals and non-metals. So my reactivity first show a decrease and then it shows a increase. Okay, so this is what reactivity is. And you always need to know the elements that are present on the extreme left, they are metals and they all act as good reducing agents, and on the extreme right we have the non-metals, so they all act as well oxidizing agents. Fine. Now when we are talking about metals, we need to speak about their oxides as well, because we know both metals, non-metals, metalloids, they form oxides. Now what is the nature of their oxides? So if I consider these elements only in the form of the oxides, we have Na2O, we have MgO, Al2O3, SiO2, P2O5, SO2, Cl2O7. Now what do we see? The metals, they usually form your basic oxides, okay, and the non-metals, they form acidic oxides. And in the intermediate we have some oxides which are known as amphoteric oxides. Sodium, magnesium oxides, they are basic oxides. This one is amphoteric, that means they can act both as an acid and base. And this one, from P2O5, SO2, Cl2O7, they are all acidic oxides. SiO2 is also an acidic oxide, but it is a weak acidic oxide. So on moving across a period, my acidity of the oxides increases, basicity of the oxides decreases. And as I move down a group, my oxides become more and more basic, so basicity of the oxides increases. So this is what about your nature of the oxides on moving down a group and across a period. Okay. Now we have diagonal relationship. Diagonal relationship, you know that the elements of the second period, they show similar properties to the elements of the third period which are diagonal to them. For example, if I consider second period lithium, beryllium, boron, third one sodium, magnesium, aluminium, then lithium is diagonal to magnesium, so these two possess similar properties. Beryllium diagonal to aluminium, so they possess similar properties with respect to atomic size, ionic radius, etc. Okay. Last one, we have some anomalous behavior. Anomalous behavior means, if I talk about the elements like group 1, from group 1 I have lithium, this is my first member because hydrogen is not a metal. From group 2 I have beryllium, group 13 I have boron, 14 I have your carbon, 15 I have nitrogen, 16 oxygen, 17 your fluorine. So these are the first members of each group, right? So this first member, they show some different properties with the other members of the respective groups. Now why do they show these different properties? And this is only known as your anomalous behavior. First reason is that they have minimum size, their atomic size is very, very small. Second is they do not contain any vacant d orbitals. Third, their charge by radius ratio. Charge means basically the valency. Radius means their atomic size. So charge by radius ratio is very, very high. Okay, and they all possess high electronegativity, which makes them, now this fourth property makes them different from the other members of the group. Okay, so this is what your anomalous behavior is. So that's it, class 11. Thank you.